Chapter 6 of Geometry, Section 1, the polygon angle sum theorems. Our objective for today is to find the sum of the measures of the interior angles of a polygon and to find the sum of the measures of the exterior angles of a polygon. So this first problem here we're going to do, it says sketch a convex pentagon, hexagon, and heptagon. What that means is that all of these vertices are pointing outwards like that. There's a pentagon with 5 sides, hexagon has 6 sides, and a heptagon has 7. Not the best artist in the world, but you get the picture. So what it wants us to do is draw all the diagonals you can from one vertex. So here I have 1, 2, or 2 diagonals I can draw. 1, 2, 3 that I can draw, and here I'm going to have 1, 2, 3, 4 that I can draw. It says, what conjecture can you make about the relationship between the number of sides of a polygon and the number of triangles formed by the diagonals from one vertex? So what that means is if you look in here, okay, if I draw these diagonals here, I have 1 triangle, 2 triangles, 3 triangles. Here I have 1, 2, 3, 4 triangles. Here I have 1, 2, 3, 4, 5 triangles. So, having done this, how many triangles do you think you can form with diagonals of a nonagon? A nonagon would have 9 sides. Can you make any predictions about that? So think about that. Think about that as we move on and look at some of these. So here we have a theorem. First off, let's think about some essential understandings. It says the sum of the interior angles measures of a polygon depends on the number of sides the polygon has. So this theorem set is the polyangle sum theorem. And so what it says is the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. And that n, really what that stands for is the number of sides. Okay, so if I have like a pentagon, it would be considered as a 5-gon in this case. So the sum of the interior angles would be 5 minus 2 times 180, whatever that answer would be. So now let's move on. Angle sum. It says, what is the sum of the interior angle measures of a heptagon? How many sides are on a heptagon? Well, we drew a heptagon in the last slide. A heptagon really has 7 sides, so we know that if we're going to use the n minus 2 times 180, we're going to use 7 for n, so we get 7 minus 2 times 180. Pull out your calculator, do that math, and you should get 900. So the sum of the interior angles of a heptagon is 900 degrees. So what is the sum of the interior angle measures of a 17-gon? The sum of the interior angles measures of a polygon is this much. How can you find the number of sides in the polygon? Pause the video here and take the time to find those. So now you can check your answers with mine. For the first one, the sum of the interior angle measures of a 17-gon is 2700 degrees. And to find the sum of the interior angle measures of a polygon being 1980, how can you find the number of sides? Well, I used that equation that we know, and I plugged in the answer, and I solved for n. N is 13, so it's a 13-gon. There you have it. So here are some just terms you need to know. An equilateral polygon is a polygon with all sides congruent, and that's how we notate that with a little hash mark on each one of them. An equiangular polygon is a polygon with all angles congruent, and each one of the angles has one little arc, or the same amount of arcs drawn on it. That means they're the same. And a regular polygon is a polygon that is both equilateral and equiangular. So all the sides are the same length and all the angles are the same measure. And this is really important. So only regular polygons have those. So you can have a polygon that doesn't have all that. It's just irregular. So here's a corollary to the last theorem that we talked about. It's corollary to the polygon angle sum theorem. And what it says is the measure of each interior angle of a regular n-gon is n minus 2 over 180 divided by n. So if you look in this picture down below, it's a picture of a fly's eye. And what it's saying is that each one of these angles is going to be, I can find its measure using that formula above. So all of these, since this is regular, are all the same measure. So I notated it just like that by drawing those in. If I count the sides, there's 1, 2, 3, 4, 5, 6 sides. So I use the formula. I use 6 minus 2 times 180 over n, which is 6. So get 4 times 180 over 6. So each angle then measures 120 degrees. That's what this theorem, that's why this theorem is important and how it's helpful. Alright. So what is the measure of each interior angle in a regular nonagon? Pause the video here and complete that. Inside, so you plug in a 9 for n and you get that each interior angle is 140 degrees. Alright, so here I have a polygon. It's polygon TODAY, or today. And I need to find the angle measure of angle Y. So we know a few things. First off, we know all the other angle measures. Okay. And if you count the sides of this, this is a 1, 2, 3, 4, 5-sided figure. So this is a pentagon. And that's really important because you know a theorem that tells you the sum of all the interior angle measures of a pentagon. And that's our polygon angle sum theorem. Our n minus 2 in parentheses times 180 is what all those different angles would be added up together. So why is that helpful? Well, if we know what all the angles are added up together, including what y is, we'll take away all the other ones, and whatever's left over is going to be the measure of angle y. So we can plug this in, figure out how much they shall add up to. 5 minus 2 times 180 is 3 times 180. 3 times 180 is 540 degrees. So all those angles should add up to be 540 degrees. So let's add up the ones we know. We know that T is 110. O, it's got that little square box. You remember that means it's 90 degrees. D is 120. A is 150, and we don't know why. So we're gonna add up all the other ones, and then we'll figure that out. So if we add all those up, we get 110 plus 90 plus 120 plus 150 is 470. So what's the difference between 540 and 470? We'll do 540 minus 470. What do you get? You get 70. So the measure of angle Y equals 70 degrees. And there you have it. So in this got it section, it's the same concept. You're going to find the measure of angle G and EFG. So pause the video now and do that. 102 for your answer. So the measure of angle G equals 102 degrees. Check my work, see if it agrees. Alright, so the next thing we're going to talk about is exterior angles. So you can actually draw an exterior angle off of any vertex of a polygon just by continuing one of the lines. So the figure below shows that the sum of the measures of the exterior angles, one at each vertex, is 360. So that means that if I add up all of these different sums, okay, here I have all of these different exterior angles, 80, 130, and 150, I get 360. 115, 71, 99, 75, I get 360. So it worked with a triangle and it works with a quadrilateral. And in fact, it actually works with any polygon. So we actually have a theorem for that. It says The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. For the pentagon, shown right here, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 is 360 degrees. So let's actually do some problems with that. Here I have an octagon, and it's a regular octagon. What does it mean to be regular? Again, go back, look through your notes. To be regular, it means it has that all of the sides are congruent and all the angles are congruent. So if all of the interior angles are congruent, what do you think that says about the exterior angles? It says that I would say that the exterior angles are also the same. So if we think about that, how many exterior angles are there? Well, there's 8 because it's an octagon. So if you think about that, 8 times the angle measure, well, let's call these angle measures A. 8A equals, well, how much do all the exterior angles add up to in a polygon? They add up to 360, so 8A equals 360. If we solve that, what does A equal? A equals 45. So if the angle right there is 45, then that means that the measure of angle 1 is 45 degrees. Alright, same thing on this next problem. Pause the video and do it. Alright, you can check your answer with mine. I got 40 degrees. This is the end of section 1 of chapter 6, Geometry.